Okay, so we're going to get into balancing equations today. Balancing equations is what we do to satisfy the law of conservation of mass. And the law of conservation of mass basically says whatever I start with, the mass that I start with, I also have to end with. Mass can't be created or destroyed. I have to account for all of the atoms that I started with. They don't just disappear. So I have to make sure that on my reactant side, the number of atoms equal the number of atoms on the product side. And so we're going to do a couple examples. I'm going to show you how to do a couple. So if we have Na plus Cl2 yields NaCl. So here's how I do it. So the arrow kind of is like your equal sign. You have your reactants on the left, your products on the right. So I need to make sure that everything on the left side of the arrow is equal to everything on the right side of the arrow. But I can only add coefficients in front. These big numbers in front are called coefficients. I cannot change the subscript. So the way I like to do it is I write underneath the arrow, I write all the elements that are involved in this reaction. So in this case I have Na and Cl, and then I count up how many are on each side. So on the left side I have 1 Na and 2 Cls because it's Cl2. Then on the right side I have 1 Na and 1 Cl. So basically I have to have these numbers equal on both sides of the elements. The NAs are good, but the CLs are not. So this one has 2, this side has 1. And when I put something here, it distributes to everything. It's kind of like a multiplying in math. So I need to figure out what times 1 will give me 2. And hopefully you understand that 1 times 2 will give me 2. So I'm going to put a 2 there. That changes the Cl to 2, but then since the Na, the sodium, is also attached, it's going to change to 2 as well. Okay, so now my Cl's are balanced, but then that made my Nas unbalanced. So I need to go over here, and I'm going to have to put a 2 here, and then that changes that to 2. So now it's balanced, and then if there's a blank after everything's balanced, you just put a 1. So in front of the Cl2, I'm going to put a 1. Okay. All right, let's try another one. Aluminum plus iron 2 nitride yields aluminum nitride plus iron. Okay, so I have aluminum, iron, and nitrogen as my elements in this reaction. On the left side I have 1 aluminum, 3 irons, 2 nitrogens. On the right side I have 1 aluminum, 1 iron, 1 nitrogen. Okay. So I'm going to go ahead and do the nitrogen first. It doesn't really matter. Sometimes I like to go top to bottom. It's kind of a trial and error thing. There's not like a set way of doing it. But I have 1 over here. I have 2 over here. So I'm going to put a 2 right here. That's going to give me my 2 nitrogens. Then that also changes my aluminum to 2. So then I'm going to have to put a 2 here to change that aluminum to 2. And then I would need a 3 here to change my iron to 3. Then everything's balanced. Again, these numbers like top to bottom don't need to match up. It just was a coincidence that they were all 2 here. as long as it's the same on both sides of each element. So just because this is a 3 for the iron does not make it unbalanced. The irons are balanced on both sides. Okay. Let's try a little bit trickier one, maybe. C7H17 plus O2 yields CO2 plus H2O. If we go back to the top, this is a synthesis reaction, just for the type of reactions, if you remember from the other day. This is a single replacement reaction. And then this one that we're doing right now is a combustion, because you have hydrocarbon plus oxygen yields carbon dioxide and water. So we have CHO. We have 7 carbons, 17 hydrogens, 2 oxygens, 1 carbon, 2 hydrogens, and then with the oxygens we have 2 over here plus this 1. So if we have multiples, we need to add them together. So 2 plus 1, which would be 3. Okay. So with combustion reactions, the oxygens are going to be the hardest to balance. So always save the oxygens for the end to do them. So with this one, I already know that's going to be a little bit tricky because the hydrogens, 2 times what equals 17? Anybody? Anybody? Well, that's going to be some sort of decimal number, and we can only put whole numbers here, so that's not going to work. So I already know I'm going to have to double this because I need this to be an even number. So that's going to be 34, and this is going to be 14. Okay. So here is, I'm going to put a 14 here to make this 14. That's 29 oxygens. 28 here, and then 14 times 2 is 28 plus this one over here. All right, and then what times 2 equals 34? I believe that's 17. So that gives me 34 of those. 17 plus 28 is 35, 45 oxygens. Okay, here's another point. I have 2 oxygens here, 45 over here. Okay, so 2 times what equals 45? It's some decimal, 22.5 or something like that. So again, I can't do that. So this is where, if we get to a point where we have everything else balanced on our oxygens, we need some sort of decimal number to balance it, then what we have to do is double everything we just did. So instead of this being 2, it'll be a 4. So this being 14, it'll be 28, and this will be 34. Okay? So this will be 28, 28. This will be 68, 68. And then this will be 56 and 34. So that's 90. And then this will be 45. Now those are really high numbers, but I was just showing you that sometimes you may go through and then you get messed up at the end, so you have to go back and kind of fix everything, but don't be afraid to do that because you need to get to it to be able to balance it correctly. So I hope this helps. Let me know if you have any questions.